Going to take a look at section 7.4 properties of logarithms today. So our targets for the day are I can use or apply properties to simplify logarithmic expressions, and I can translate between logarithms in any base. So we're going to take a look also at an application here with these as well, and I think you're going to find out it's a pretty cool topic, although it's a little interesting to work with at first. Because remember, there is a direct relationship between logarithms and exponents. What do I mean by that? Well, you saw in the last section that you can convert between exponential and logarithmic form and logarithmic and exponential form. So you shouldn't be shocked to hear that the properties of exponents that you've learned and you've known since the very beginning of the year in chapter 1 hold true. Here's what I mean. So for the product property of logarithms, this compares very well to our property of exponents, where if you have the like base, what can you do with those exponents? As we established earlier this year, you can add them. Well, logarithms, very similarly, you can take the log of any quantity and you can express it in terms of a product, but then that product becomes the sum of the two logarithmic factors. So notice how there's 10 and 100 there and how that gets broken up, but it's dealing with this idea of the sum. So it's directly connected with this power property that we learned earlier this year. So sometimes it's better to put logs together, other times it's better to break them apart. So for us, in this first case, we're going to take a look at putting them together. So express log base 6 of 4 plus log base 6 of 9 as a single logarithm. What that would mean then is you can write log subscript 6, so base 6, of 4, and then since it's addition, that translates into this concept of multiplication. So times, that would be a base of, or excuse me, not a base, but a given value of 9. So that's log base 6 of 36, which some of you may be able to evaluate in your head at this point. I'm hoping that you can, but if you can't, remember you can always think of this in an exponential form. 6 to what power gives you 36? Think about it for a moment. Well, I think you know that answer is just 2. So when you actually express that as a single logarithm, it can simplify down. So anytime you can simplify the logarithms, you should, if it's at all possible. But it really does depend if the bases match and if you have a nice even power that when raised to, you obtain this given value of 36. All right, let's take a look at one more example, number 3. Okay, I don't want to bore you to tears. Number 2's got some huge numbers, not necessary. But I like this one because this base actually, it's a little hard to read, but it is really 1/3. These are 1/3s right here. Okay, so similar bases you were adding, you can multiply together. So you would have log base 1/3 of 27. No longer are you adding, but rather it becomes multiplication by 1/9. Which, when you simplify that down, that's log of base, 1/3 of 3. And think about that for a moment. 1/3 of what power gives you 3? Yep, I hope you got it. It simplifies down to -1. Okay? So that is the product property of logarithms. You shouldn't be shocked to see on this same page directly below the quotient property of logarithms, because it takes this concept in terms of the division of logarithms, and if you had multiplication, that was equivalent with working with the addition there. I wonder what the division is going to be equivalent to. Well, if you are a betting man or woman, hopefully not, you're still too young for that. If you had this, like this, what could you do with those exponents? You would subtract them. So this concept of division of two like bases here, subtracting those exponents, parallels very well in terms of our logarithms. So on example, just when you're subtracting logs, you can express it as a simple log. Notice, yes, we did get the directions right here. Should always say simplify if possible. Here, these logs have the same base, so we can put them together. So that's going to be log base 5. But instead of working with multiplication and addition, we're working with the subtraction, so it's the division. So the 100 comes first over the 4. Now notice how I wrote that. It's that log base 5 of that singular given value. So these two given values become divided. So that's log base 5 of 25. And not a betting man, but I think you got this one. It simplifies down to 2. Okay? Now you, of course, will see some more difficult examples, but that handles our first two properties. I hope you enjoyed.